to do is a somewhat more complicated example down here under Summary B, beryllium and chlorate. Now, the thing that makes this a lot more complicated is that the nonmetal is actually a polyatomic ion. Now, if you remember, a polyatomic ion is simply a molecule or a covalent compound that happens to have a charge, meaning that it either has lost electrons or it's gained electrons. Here, it's going to be losing electrons and gaining electrons in the context of an ionic compound. And so it's going to be the nonmetal, because it's made up of oxygens and chlorines, it's going to be the nonmetal where beryllium is going to be giving up its electrons as the metal. So I'll draw out the beryllium. That's the easy part. Beryllium has 2 valence electrons. Now I've got to draw out chlorate. Well, that's a little bit more complicated. When you're drawing out a polyatomic ion, the one main thing that you need to remember is that because this is in the context of an ionic compound, when we have chlorate, which is ClO3 1-, that 1- is the electron that this chlorate eventually gains. It will gain it in the reaction. Emphasis on will, meaning that that electron, before it reacts, has not actually been gained yet. So as I'm drawing out chlorate, I've got to make sure that I only draw the electrons in the chlorine and the oxygen and not that extra electron. So here's how. I'll put the chlorine in the middle, as I always do, with the oxygens on the outside of that. And when I add up those electrons, I've got the 7 electrons from chlorine plus 6 electrons from each of the 3 oxygens. And when I do that, I get 25 electrons. That's an odd number. And so you have to split that up. What it really means is that there's 24 electrons plus 1 electron, which is 12 pairs plus 1 electron. Well, how does that work? We start from the outside and put the 12 pairs on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I've finished the 12 pairs, but where does that 1 electron go? Well, it's going to go on chlorine. Chlorine takes the electron last because it is the least electronegative of all of the elements that are in here. Oxygen has an electronegativity of 3.5, so it's more likely to not just have 1 random electron on it. So this is the ClO3 with no extra charge. And if you look, it's pretty obvious what needs to happen. There is a spot right here that chlorate needs to have another electron from. Where does it get that electron? Well, it's going to get it from an ionic compound, from beryllium. And so what I do now is show that beryllium is actually going to donate the electron to the chlorine, and I'm going to put that X over there. Now the entire chlorine, after it's gained that electron, has a 1- charge, which is the one that you already memorized. Beryllium, however, still needs to give up one of its electrons, and so unfortunately you do have to draw this out one more time to accept that second electron from beryllium. So I'll just kind of do that quick. Oxygen, oxygen, oxygen. And then putting that second electron there. Now this chlorate has accepted 1 electron, that chlorate has accepted 1 electron, and this beryllium has lost 2 electrons, so it has a charge of +2. And you would write that out formally as follows. You have 1 beryllium, and it has a charge of 2+ plus 2 chlorates. I'm going to make this extra big so that I don't run out of space. And just sort of do a small scale version of what you had done in your rough draft and give that a 1- charge. And whenever you write out the complete chemical formula for that, it's going to be Be ClO3, 2, because you have 1 beryllium and 2 whole chlorates. You've got to make sure that you put the chlorate in parentheses because there's 2 whole chlorates, and if you didn't put parentheses there, it would look like ClO32, which is clearly ridiculous. So ClO3, 2, and this is the chemical formula.